Yes, dear students, today I am going to discuss here a graph for linear accelerated motion. Here you are given a table. This is position time graph, position, not distance time graph, position time graph. What is the meaning of position? Suppose here it is point from where a body starts in a straight line. At t equal to 0 here, at t equal to 1 second is 2 meter away, then 2 second 4 meter away from here, and 3 second 6 meter away from here, and so on. So you are given the position of the body at different times. 0 per 0, 1 per 2 meter, 2 second per 4 meter, 3 per 6 meter, and so on. So this is the table for the position of a moving body at different times. Now if you want to plot graph, xt graph, then we take position x along y-axis, time t along x-axis. Here I have marked 1 second, 2, 3, 4, 5, 6, 7, so on. Then position 2 meter, 4, and so on. And we mark the point k at 1 second is 2 meter away, at 2 second is 4 meter away, and so on, and finally at 6 meter is 12 meter away from the starting point. Don't imagine like that body going like this. Body to initially was going in straight line like this. It tells the graph tells position at different times. Nothing else. In this graph we can see we are given position of moving body at different times. For example, at 2 seconds it is 4 meter away, at 4 seconds it is 8 meter away, 8 meter away, and at 5 it is 10 meter away, and so on. Now, what is the use of learning such graphs? Actually, in science, we take many observations and then find the average value of quantities. So it will make understanding here what graph can tell. So from position time graph, what can you obtain? Informations from xt graph. Xt graph is position time graph. Number 1, we can get position of body at any time. For example, here I told you at 3 seconds, body at 6 meter away from the starting point, like that. Number 2, we can determine the magnitude of velocity from xt graph. How? By definition of velocity, v bar is equal to x2 minus x1 upon t2 minus t1. By definition of velocity, v average, I should write here v average. Change in position for a magnitude होगा, magnitude, not vector velocity. Now, if in graph you see, I take time t1 here at 2 seconds, t2 at 6 seconds. At 2 seconds, the displacement is 4 meter. At 6 it is 12 meter. I take t1 this, so this is x1, t2 this, so this is x2. So this thing is left only x2 minus x1, and is left t2 minus t1. So from graph uh, from this graph, xt graph in figure, xt2 minus x2 minus x1 upon t2 minus t1 comes out tan theta, which is equal to slope of xt graph. That way, by finding the slope of the xt graph, we can find average velocity. So I can say here, by calculating the slope of xt graph, we can find a magnitude of average velocity. And here we conclude that wherever we take T1, T2, the average comes same. So if xt graph is a straight line making certain angle theta with time axis, then magnitude of average velocity magnitude of average velocity and instantaneous velocity are the same. Yani whatever the average velocity, the same will be the instantaneous velocity. And secondly, greater the slope of xt graph, faster the speed, faster the velocity. If slope decreases and becomes zero, when it becomes zero, if you know xt graph come like this, then position not changing, then body at rest. So here you can say if xt graph is a straight line parallel to time axis, then slope is zero, hence magnitude of velocity is zero. but it will be very quite apparent from the graph. Okay, at this time position same, here same, the body is at rest. So you can say directly if xt graph is a straight line parallel to time axis, then body is at rest. Now what happens if the graph is a curve? If the graph is a curve and those curves may be of different shape, time or x means position or this time. Suppose the graph come like this, or it may be like this. जरूर कैसी हो xt graph may be like this also. So what is happening there? Average speed and instantaneous speed will not be same. In these two graphs, position time graph, average velocity and instantaneous velocity will not be same. So average magnitude of average velocity again we can find it t1, it is x1, it is t2, and this is x2 here. So again this is x2 minus x1, this is t2 minus t1. So ratio of xt2 minus xt1 again will give average velocity, x2 minus x1 upon t2 minus t1. It is again, but here now instantaneous velocity will keep on changing. So how to find instantaneous velocity? Instantaneous velocity is equal to slope of tangent to the curve. At instant of time. Instantaneous means speed, velocity at any time. Suppose you want at this time here. So what we do? We draw tangent, and this slope of tangent tan theta will give the again. So here instantaneous velocity is equal to slope. So that is instantaneous velocity is equal to slope. Here the slope is increasing. Here the slope here, if I go this here, if I take tangent at this point, come this, and here if I take it goes parallel. So when it comes like this parallel tangent, the speed becomes 0. So when slope of xt graph is increasing, then velocity increasing, and if decreasing, so velocity decreasing, and finally it comes to rest here. After this time, body will not move. So these are some informations which you can obtain from position time graph. And I have told you that magnitude of average velocity at any time is equal to speed also. Now next topic here will be velocity time graph. I will take in next video.